Hello students, this is lecture number 2 of the topic Some Basic Concepts of Chemistry. In the previous lecture, we had studied about what we call as language of chemistry. Today we will learn about another tool which will help you to go ahead in the subject of chemistry, and that is about different types of measurements, their units and their conversions. This topic even is very important when you go for physical chemistry in lot other topics. So the first point is about when we carry out any kind of measurement in the chemistry practicals, this particular measurement is reported with two things. Number one is going to be the numerical value, and number two, along with it, its unit. For example, if you say length measured is 5 meter, over here numerical value is 5 and the unit is meter. So what do we mean by the term unit? Unit is any arbitrarily decided, universally accepted standard which measures the physical quantity of matter. Now, units have been in use in science for several years. And one of the type of system of unit you can see was called the FPS system, also known as the British system. The FPS stand for foot for length, pound for mass, second for time. This is comparatively an older system and hardly in any use. But still, in our country, we still represent height of a person in feet. Pound mass is not much in use in most of the countries. The second system is called CGS system, which stands for centimeter for length, gram for mass, and again second for time. Along with CGS, another system which was developed was MKS system, which stands for meter, kilogram, and second. Over the years, you can see systems have changed for length and mass, but the unit of time over the several years of measurement has remained the same. After few years, or rather few decades, people started feeling that we should not have different systems as per our wish. So they started with a proper system of units known as SI unit system. SI unit system has first concept called fundamental unit. That means all the other units, all the other measurements are derived from them, but these are not derived from anyone else. There are 7 basic SI units considered, and they are length, unit is meter, mass, the unit is kilogram, time, once again second, electric current, ampere, thermodynamic temperature, Kelvin, amount of substance, mole, and luminous intensity of light, candela. In chemistry, we are more concerned almost with first 6 types of units here. Luminous intensity is not much required in chemical calculations. To express these fundamental units, whenever there is a bigger number, a prefix or a multiple is used. For example, when we have a unit, the measurement as 5,000 gram, we can express it as 5 into 1,000 gram. Now, this 1,000, also you can call it as 10 raised to 3, is given a term called kilo. So instead of writing 1,000 gram, now we can write kilogram. You have been using the term kilo, milli, just without any understanding. Now we have to see what is the exact meaning of these units. So see the left hand side column of the table, which are negative powers of 10. So 10 raised to minus 1 is a deci, 10 raised to minus 2 is centi, 10 raised to minus 3 milli. Now observe the table values here. After milli, the values or the powers of 10 leap by 10 raised to minus 3. So 10 raised to minus 6 micro, minus 9 nano, minus 12 pico, minus 15 femto, minus 18 atto, minus 21 zepto, and minus 24 yocto. All these are negative powers of 10. If you consider the positive powers on the right hand side written in red, 10 raised to 1 deca, 10 raised to 2 hecto, 10 raised to 3 kilo. After that, once again, powers of 10 leap by 10 raised to 3. So 10 raised to 6 mega, 10 raised to 9 giga, 10 raised to 12 tera, 10 raised to 15 peta, 10 raised to 18 exa, 10 raised to 21 zeta, and 10 raised to 24 iota. We will also learn how to convert one type of multiple into another in some time. Before that, let us come to the measurable properties. In science, which are the measurable properties we use? First among them is mass or weight. In school, you must have studied the difference in them. You know, the mass is the amount of matter present in it, while weight is the force exerted by the gravity on a particular object. So you must have heard mass of a substance is always constant, while weight of the substance can change from place to place on a planet or on different planets because gravitational force changes. The main conversion unit, what you should know and learn by heart, is 1 kilogram is 1000 gram. Those who feel 10 raised to 3 little uncomfortable, for them you can remember 10 raised to 3 as 1000 or 10 raised to 6 milligram. You know, you can make this conversion reverse also. For example, you can take this particular thing as, suppose 1 kilogram, I'm just writing it for simplicity, 1 kilogram is 1000 gram. Milligram comparatively is much lesser needed unit. We will be more using this as gram unit only. I will give you after some time some shortcuts to remember these units also. Before that, let us go ahead. The second one which we are going to use is volume. Volume, as you know, is the amount of space occupied by a substance. You know, when you measure volume, what we imagine is a cubical space. So for example, imagine you have a cubical space this way. And since SI unit of length is meter, they consider this is a box made up of 1 meter by 1 meter by 1 meter. So the volume occupied in this box or cage will be 1 meter into meter into meter, that's meter cube. That becomes the SI unit of volume. You know, other volumes which are more popular are liter and milliliter. Liter, it's same as decimeter cube. Milliliter, it's same as centimeter cube. So unit conversions, you can understand and remember them by heart. 1 liter is 1000 milliliter. Now you can understand liter is same as decimeter cube and milliliter is same as centimeter cube. So giving a complete conversion of all the units, this relation you can see. 1 milliliter, it's same as 10 raised to minus 3 liter, 10 raised to minus 6 meter cube. You can even write this in a reverse way also. 1 meter cube is equal to 10 raised to 3 kilogram, 10 raised to 6 centimeter cube. Both the ways the units work. So far we have seen the two units called mass and volume. On which instruments do we actually measure them in laboratory? One of the instruments which we use for volume measurement, we have shown over here. So volume can be measured on one of the thing known as burette. Now burette is an instrument along with pipette is used for what is known as titration analysis. You will have a chapter later where we will study about titration and practicals. Third one is graduated cylinder, where you can see measurements of different volumes are written. There is another one called volumetric flask. This instrument is used if you want to measure a fixed particular volume. For example, on this diagram, you can see there is 1 liter written. So this only will measure 1 liter directly, not less, not more. Another instruments which we are going to use for mass measurement, and I have deliberately shown some old and a new one. This is an old instrument known as analytical balance. This is a comparatively modern instrument known as one pan balance. So on these two, we are going to measure the masses. Continuing further with other measurable properties, the most common one used in science is temperature. The SI unit is called Kelvin, and other popular units are degree Celsius and degree Fahrenheit. On olden textbooks, they used to write it as degree centigrade, but Celsius is a correct term. Major important thing is how do we convert these units? So first conversion we remember is temperature in Celsius multiplied by 9/5 added with 32 gives you temperature in Fahrenheit. So this is a conversion of Celsius to Fahrenheit. Second one is conversion of Celsius to temperature in Kelvin. Just add a factor to 73.15 and you will get Celsius converted into Kelvin, or even vice versa. Rather than remembering these two conversions, I will suggest you to remember a third common and easy conversion. In this single conversion, you can convert Celsius to Fahrenheit, Celsius to Kelvin, Kelvin to Fahrenheit, or Fahrenheit to Kelvin. Any direction using this single equation, we can do all the conversions possible. Fine. Let us go ahead further. This is a diagram where all the three different scales have been shown together. One is a Kelvin scale, second is Celsius, and third is Fahrenheit. Now, we are going to write over here the different values what you see from the thermometers. So let us consider freezing point of water. So in Celsius scale, you can see this as 0 degrees Celsius. At the same time, Kelvin scale, you can see this as 273.15 Kelvin. And the freezing point in Fahrenheit scale is 32 degree Fahrenheit. If you compare the boiling point of water, in Celsius scale, it is 100 degree. Kelvin scale, it is 373.15 Kelvin, or you can either write it as 373 Kelvin also. And 212 degree Fahrenheit in the Fahrenheit scale. Similarly, if you check room temperature and human body comparison, so room temperature is taken in Celsius as 25 degrees Celsius, which becomes 298 Kelvin, and in Fahrenheit scale, it is 77 degree Fahrenheit. Human body without any fever, a healthy human body is supposed to have 37 degrees Celsius, which is 310 Kelvin and 98.6 degree Fahrenheit. You know, when doctors do tell you that you have a fever of 100, they are basically referring to 100 degree Fahrenheit. A very severe fever of 103 or 104 in certain diseases is the Fahrenheit scale which doctors refer. So basically, in our daily life, we use Celsius scale. In a scientific calculation, we use Kelvin scale, and medical doctors, professionals, they use a Fahrenheit scale for human body temperature. Continuing further with measurable properties, one of the most important one which we'll be using more in 12th standard will be pressure. Now you can see over here, the very first one written is called atmosphere, and the conversion is 760 millimeter of mercury. So what is this particular thing? This is a kind of an instrument we use known by the name manometer, also sometimes referred as barometer. There is of course a minor difference in both of them. We will pick up a term barometer for our reference. Barometer contains mercury in the reservoir. Barometer contains mercury in this tube. What they do is they measure the height of mercury over here. When this is placed at a sea level, the height of this mercury comes out to be 760 millimeter. This pressure at sea level is considered as 1 atmosphere. Converting this into different scales, you can have a scale of Pascal. This is known by the name Pascal, a scientist who worked in measurement of pressure. So 1 atmosphere is also 1.013 into 10 raised to 5 Pascal. Pascal in SI system becomes Newton per meter square. 1 atmosphere is also same as 1.013 bar. Bar is another unit coming from the word barometer. 1 bar is also 10 raised to 5 Pascal because Newton per meter square is same as Pascal. Another term which we are going to use in measurable properties is density. As you know, density is made up of mass upon volume. So simply write down the units of them. Mass unit is kilogram. Volume SI unit is meter cube. So SI unit of density becomes kilogram per meter cube. Actually, the popular unit which we are going to use in many chapters will be gram per ml. After doing so many of conversions, my suggestion is you should write them down multiple times, by heart them. But still, for our exams like JEE, NEET or CET, I will give you some shortcuts. Listen to this very carefully, practice them, learn them by heart. First is for mass. So 3 main conversions come across in our exams. First, if you have a milligram value, multiply by 10 raised to minus 3, it will become gram. If you have a gram value, multiply by 10 raised to minus 3, it will become kilogram. If you have a kilogram value, multiply by 10 raised to minus 3, it will become gram. These are conversions for mass. Let us use a conversion for pressure and watch the trick very carefully. I first write a series of numbers, that is 1, 760, 101, 325. These are 3 set of numbers I have written. Now, these are the units I am thinking: atmosphere, torr, and Pascal. Bar, millimeter of mercury, and Newton per meter square. Just draw 2 lines to understand how the conversion is given. So how will you read it? 1 atmosphere is 760 torr. 1 atmosphere is 101.325 Pascal. Now this number, we had written it earlier as 1.013 10 raised to 5. This is the real number. Similarly, 1 bar is 760 millimeter. 1 bar is 101.325 Newton per meter square. So in one single set, one single table, you can remember almost all the numbers. Similarly, for volume, you can write down 1 and 1000. Simple, 1 and 1000. Now remember the conversions. Meter cube and liter, liter and milliliter. Liter is same as dm cube, Milliliter is same as cm cube. Draw a line and you can understand the conversion. 1 meter cube is 1000 liter. 1 liter is 1000 milliliter. And that is same for the third one. I'm sure most of the problems, what you will do in your syllabus will be covered by this particular shortcut method of mass, volume, and pressure. I hope you have understood this much. Without fail, write them down multiple times and only practice the questions. After understanding this, let us go ahead with more conversions. Now, these are some of the problems which we will try to solve and use the convergence. I will introduce some tricks over here, which perhaps are new for you, but learn them. That will save your time. Before solving these problems, you should be very clear about the terms milli, centi, giga, kilo, micro, nano, and so on. So while learning this, in case you have not remembered it yet, keep that table in front so that you will understand easily. Problem number 1. They are asking us to remove the prefix milli and just make it into liter. So what is meant by milli? If you remember, it's 10 raised to minus 3. So instead of the letter meter, that is milli, I have written 10 raised to minus 3 followed by liter. That's all, my conversion is done. If you check the next one, I have to introduce now milli over here along with the gram. So how do we do it? You know, we cannot just introduce a unit or a prefix. The value of the number also must be kept same. So I introduce a trick. Watch it carefully. I will write the gram unit as it is, which is my target unit, is 10 raised to minus 3 milli. I will multiply by the opposite value of it, that is 10 raised to 3. So if I'm introducing 10 raised to minus 3, I will introduce 10 raised to 3. And those who are good in mathematics will understand 10 raised to plus 3 multiply by 10 raised to minus 3 is basically 10 raised to 0, which is 1. That means we are not changing the value at all. So coming back to the problem, 612 into 10 raised to 3. Now you understand 10 raised to minus 3 is nothing but milli followed by the unit gram. You can see we have done the conversion. This method, I'm sure, is a little bit new for you, but we have to learn this. Going ahead, they have given us something in giga. We want to convert it into kilo. So we write the number first. And if you refer the table, giga stands for 10 raised to 9. This is first of all removal of the term giga. Now, if I use my method of the earlier problem, we want kilo. By kilo, we mean 10 raised to 3. So I will write 10 here. I want 10 raised to 3 here. So I will introduce the opposite number. This will become 1.9. 10 raised to 9 minus 3 is 6. And this is nothing but kilo. That becomes kilogram. 8.16 into, we want now centi to be introduced. So we have 10 written over here. What is centi? Is 10 raised to minus 2. Multiplied by opposite index 10 raised to 2. So it becomes 8.16 into 10 raised to 2 centimeter. If you want, you can even shift the decimal point ahead and report the answer, or keep it even as it is, no problem. Let us go ahead. 4.18 is kilo. So kilo is 10 raised to 3. Now we want to introduce over here milli. So I will write 10 raised to 3 as it is, jaise tha pehle, and we are introducing milli over here. Once again, milli is 10 raised to minus 3. Let us multiply by 10 raised to 3. So this becomes 4.18. This is 10 raised to 3 and 10 raised to 3. That makes it 10 raised to 6. This portion becomes milligram. 1738. Kilo is 10 raised to 3. If you remove kilo and replace it with 10 raised to 3, your answer is ready. 1738 into 10 raised to 3 meter. Whenever we are doing it on the videos, all of you should pause the video, try it on your own, then only see the solution. Going ahead, now we have a mega. If you refer to mega, it is 10 raised to 6. So this is first of all removal of the mega term. Now we want to introduce kilo. So if you have understood by now, I'm going to multiply by plus 3. I'm going to multiply by minus 3. So this will become 500 into 10 raised to 3 kilogram. So I'm picking up 10 raised to 3, replacing it with the alphabet letter K. Coming next, 7 nanometer to centimeter. First of all, nano is 10 raised to minus 9. So 10 raised to minus 9. Now we want to introduce centi. Centi is minus 2. Plus 2 is multiplied. So the answer becomes 10 raised to minus 7 centimeter. 1.4 gigameter. Giga is 10 raised to 9. So I first removed giga. We want to introduce centi. So once again, the old trick repeated many times. This is a centi and this is opposite number. So 1.4, 10 raised to 11 centimeter. 0.91 into 10 raised to minus 27 is the given number. We want to introduce milli. So milli is 10 raised to minus 3. Add it with plus 3. So that becomes 0.91, 10 raised to minus 24 milligram. Going with further more conversions now from temperature section. So we have Celsius to Fahrenheit conversion. So how do we write this particular thing? We had the unit or the conversion written earlier. Temperature in Fahrenheit is 9 by 5. Temperature in Celsius plus 32. So 9 upon 5 multiplied by temperature plus 32. Now this becomes 5 5s are 25. So this becomes 45 plus 32. So temperature becomes over here 77 degree Fahrenheit. Temperature in Celsius to be converted into Kelvin. So temperature in Kelvin is temperature in Celsius plus 273.15. So it's 40 degrees Celsius plus 273.15. So it's going to be how much? 313.15 Kelvin. I think by now you must have seen that we write Celsius with degree, Fahrenheit with degree, but Kelvin is only Kelvin, not degree. Degree Kelvin is a wrong thing. Now the conversion is given from Kelvin to Fahrenheit. You know, there is no direct relation. You might have to do 2 steps. So recall the shortcut which I gave you on the previous screen. Temperature in Fahrenheit minus 32 divided by 180 is temperature in Kelvin minus 273 divided by 100. Now this becomes very simple because it's 273 minus 273 over 100. is temperature in Fahrenheit minus 32 upon 180. So if you are calculating this, right hand side becomes 0. 180 taken on that side becomes 0. So temperature becomes 32 degree Fahrenheit. 60 degree Fahrenheit to Celsius. I'm going to use this shortcut once again. Temperature in Fahrenheit minus 32 upon 180 is temperature in Celsius upon 100. So this is going to be 60 minus 32 upon 180 equal to temperature in Celsius upon 100. So upon solving, I think you can get the answer as around 15.5 degrees Celsius. You merely need practice for these problems, nothing else. Let us now come to the second part of our chapter, that is scientific notations. You know, in chemistry, we come across sometimes very large numbers or very small numbers. So all the numbers are now scientifically to be expressed in the format given here as n into 10 raised to n. So whenever a number is given, shift the decimal point and make it into this format. For example, if you are given a number 232.508. So, you know, we are going to shift the decimal point after the first digit. So my number will be 2.32508. Multiply by 10 raised to. The rule is, if you are shifting it to the left, the power of 10 will be positive. I have shifted the decimal point 2 places to the left. So this will be 10 raised to 2 positive. Suppose we want to shift the decimal point on the right hand side. So I want to express the number as 1.6. I am shifting it how many places? 1, 2, 3 and 4. So this becomes 10 raised to minus 4. Ensure that all your answers in numerical problems are always expressed in scientific notations. Even in the papers of JEE and NEET, all the answers they express in multiple choice questions are also in this format only. So let us practice few numbers of this system. So here we want the decimal point over here. So it's going to be 6.968 into 10 raised to. We have shifted it 1, 2, 3 and 4. So this becomes 10 raised to how much? Minus 4. We have shifted the decimal point to the right hand side. Second, 1.57428. You know, the question is, where is the decimal point in this number? It is over here. If you can't see the number, decimal point, understand it's at the end. So you have shifted it to place number 1, 2, 3, 4 and 5 to the left hand side. So it is 10 raised to 5. Practicing this one more time. 9.12340 into 10 raised to. So where was the decimal point? At the end. We have shifted it how many places? 1, 2, 3 and 4. That is 4 places on the left hand side. Let us practice this more. 8.434 into 10 raised to. We have shifted it to the 2 places on the left. So this will be plus 2. 4.21 into 10 raised to. Shifted it to 1, 2 and 3 places, minus 3. 6.49 into 10 raised to 1 and 2, minus 2. 3.275 into 10 raised to. Shifted 1 and 2. So 10 raised to positive 2. In the videos, whenever you are seeing the questions, problem solving, try them on your own, then only see the solution. Let us go ahead with more concepts about this calculation purpose. How do we use these terms over here in addition and subtraction? How do we use them? You can see, first of all, whenever addition, subtraction is given to you, check the powers of 10. And first thing is they must be similar. So what we can do over here is 6.65 into 10 raised to 4. Let us try to make this power also as 10 raised to 4. For that purpose, I can write this as 0.895 into 10 raised to 4. If I do the addition here, power of 10 remains the same, and we can do the addition and get the final answer. So while doing the addition, rule is powers of 10 must be similar, otherwise your answer will go wrong. Try in same manner over here. This is 10 raised to minus 2 and 10 raised to minus 3. So suppose I keep this as 2.5 and 10 raised to minus 2. If I want to make this as power of 10 raised to minus 2, then this will become 0.48 into 10 raised to minus 2. Now we can subtract them safely. Power of 10 remains as it is. And answer will be, I think, 2.02 10 raised to minus 2. When you are going for multiplication of such numbers, you can be little easy because everything is multiplication. So you don't have to worry. This is simply 6 into 5, that's 30, into 10 raised to 5 plus 8. So the answer is 30 into 10 raised to 13. Or suppose you want to shift the decimal point and report this, it can be this way also. Going ahead, 2.7 multiplied by 3. Now we are going to simply, there is a division out here. So this is going to become now 2.7 divided by 3 into 10 raised to minus 3 into 10 raised to minus 4. So one part you can see is 2.7 divided by 3. That answer is 0.9. 10 raised to minus 4 from the denominator when goes to the numerator, this becomes a positive number. So the answer becomes 0.9 into 10 raised to 1, or 9 into 10 raised to minus 1 into 10 raised to plus 1, or simply answer becomes 9. Those who are a little bit weak in mathematics have to please go through this carefully, properly. Let us go ahead with similar more calculations of this pattern. 6.8 into 10 raised to minus 9 divided by 2.2 into 10 raised to minus 6. So once again, I'm requesting pause the video, do it on your own, then check my answer. So 6.8 10 raised to minus 9 divided by 2 into 10 raised to minus 6. So this will become 3.4 minus 9 plus 6. So this is 3.4 10 raised to minus 3. Once again, there is an addition, and you can see 10 raised to 3 and 10 raised to 2. So what can we make? Let us try a little different way now. Let us make this 10 raised to 3 as 10 raised to 2 and 10 raised to 1. I'm splitting the number. 2.62 into 10 raised to 2. So this will become 45.6 into 10 raised to 2 plus 2.62 10 raised to 2. So when you do the addition, this will become 2, carry 1, 8, and 4. Once again, you have 10 raised to minus 3 and 10 raised to minus 4. So let us say this is 9.87, 10 raised to minus 3 as it is. This I am making 2.26, 10 raised to minus 1 and 10 raised to minus 3, splitting the indices. So this is 9.87, 10 raised to minus 3 minus this multiplication becomes 0.226, 10 raised to minus 3. So now we are left with 9.87 subtracted with 0.226, 10 raised to minus 3 common in both. 10 raised to minus 3 will remain as it is. Try doing this subtraction. 9.87 minus 0.226. That's, I think, 9.644. This gives you a simple calculation. We come to another concept called significant figures. You will be having this concept again, perhaps in physics also. But in chemistry, we need it, more important for JEE and NEET. Whenever you are measuring the number of digits or in a particular measurement, there are some meaningful digits which are known with certainty. You know the measurement correctly. And there are some uncertainty with the remaining digits. This is called significant figures. Let me explain it. Suppose you have a piece of gold with you. Listen to this example carefully. You go and measure it on a balance number 1. The gold piece is weighed as 2.0 gram. Fine. You go to another shop and check the weight. They have a little different balance. They give you the weight as 2.01 gram. Now you are a little suspicious. You go to third balance and you find the weight as 2.012 gram. Now you can understand everywhere the number 2 was coming same. And the numbers rest after the decimal point are changing as per the accuracy of the device. So over here, the certain digit is definitely 2. And the doubtful digit what you see are after the decimal point. That means in case number 1, the balance was not a very accurate one. It gave only that much result. This tells us about the information about significant figures. So now if you want to really find about the significant figures, this is not the way to do. In fact, we will have a set of rules to understand. Depending on what kind of numbers are given to you, different rules are used. So let us say we are having this kind of set of examples given. So rule says all non-zero digits are significant. So let us calculate. Over here, 7 and 9. So significant figures are 2. 3, 1, 4. Significant figures are 3. 1, 2, 3, 4. 4 significant figures. So if your numbers are of this pattern, where there is no zero at all anywhere, the counting is very simple. This is rule number 1. We will try to make different type of numbers over here. So suppose this is second type where zeros are incorporated. So how do we find now this particular thing? Read the rule. Zeros to the right of the decimal point are significant. So here this is significant. Of course, this is significant. 2 significant numbers. 7 significant. Both the zeros are significant. Total are 3. So zeros after decimal point carry weightage. They are important numbers. Let us say rule number 3. Rule number 3 says zeros to the left of the first non-zero digit are significant. So, are non-significant. So over here, 3 and 2 will be significant. 2 will be significant. 1 and 8 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 0.324, 3, 2, and 4. All three are significant. So, talking more about different numbers, zeros between the non-zero digits are also significant. So 1, 2, 3, 4, 4 significant digits. 1, 2, 3, 3 significant digits. 1, 2, 3, 4, 4 significant digits. Over here, 1, 2, 3, 4, 5, all are significant digits. Coming more to the rules. If notations are given in this format, the scientific notations, we have to completely ignore the powers of 10. And significant digits are only counted for rest of the points. So 4.01, there will be 3. 8256, 4 significant. 1.86, 3 significant. 6023, 4 significant figures. Rule number 6 tells you about counting when objects are given. And it's very funny that we do not know the exact numbers. We just take the significant figures as infinity, infinite number of significant figures. After significant figures, we have some problems to solve. You can pause the video, check it again, and then continue with solving, checking my. So let us calculate the significant figures in case you have tried them. 6005, all 4 are going to be the significant figures here. So this will be 1, 2, 3, 4, 4 significant figures. Power of 10 is not counted. The rest of the numbers are seen. 4, 8100, 4 significant figures. 0 here and 0 here not counted. So 5 and 8, only 2 significant figures. This was a question asked long back in NEET 1998. So 161 centimeter. So we have 1, 2, and 3. 3 significant figures. 161. There will be 3 significant figures. And again, 161. There will be 3 significant figures. Going ahead with some last concepts remaining. Precision and accuracy. Precision is a closeness of various measurements. Remember this term? Closeness of various measurements. Accuracy is the agreement between the measurement and the true value. Let us understand it with an example. Suppose we are making a measurement of mass and we know that the true value is, let us say, 2 gram. 2 gram is the real value. Suppose different persons are measuring this as per their knowledge and instrument. Person A measures it 2 times. Let us say his measurements are coming as 1.95 gram, 1.93 gram, average is 1.940. Similarly, person B gets an average of 1.995, person C 2.0. So you can see the difference here. Persons A, measurement 1 and measurement 2 were coming very close. So coming to the definition, closeness of measurement. So we can say his measurement is precise, but it is much away from 2.00. So we say it is non-accurate. Second person's measurements are different. 1.94, 2.05. So they are neither precise and even they are not exactly with true value. So not accurate also. Person C, measurements are quite nearby. Average is exactly same as the true value. So this is going to be the winner with precise as well as accurate measurements. To understand this particular concept, we have this kind of thing where a dart game is imagined. And if you hit the bull's eye, then it is accurate and precise. So in first case, 4 different darts are going to be at the bull's eye. So they are precise and all are hitting at the true value. So they are accurate. Second case is little funny. He is getting all 4 cases at a similar place, but they are much away from the real goal. So not accurate, but precise. Next case, you can see they are accurate, but not precise. And last, everyone is haywire, so not accurate, not precise at all. Next is the case of rounding of the digits. These are all mathematical tools we are learning today, which you will be using in physical chemistry chapters. So when you are rounding off some digits, what are the different rules we follow? So suppose we have been given this kind of number. The number to be removed is 6 and this is greater than 5. So the previous digit will be increased by 1 unit. So when digit removed is more than 5, previous digit is increased by 1. Suppose the digit to be removed is less than 1, then the number previous digit is kept as it is. Most of you know these particular rules, but case number 3 is a very interesting one. The one which you want to remove is 5 itself. What we saw was less than 5, greater than 5. So exactly it is 5. Check the previous number. If it is an even number, it will be kept as it is. But if the previous number is an odd number, you increase it by 1 and make it even. These rules are usually ignored by students and they are asked in exams. Let us calculate this round off to the 3 significant digits. This will cover your rounding off concept along with the significant figures. So my number is 4.309251. We want 3 significant digits. So where are they? Over here. So the digit you want to remove is 9. It is greater than 5. So we have to add 1 to the previous. Here I am going to add 1. Significant figures 3. So my answer should end over here. Digit I want to remove is greater than 5. So the answer will be 49.8. We want 3 significant digits. Digit to be removed is greater than 5. So this will be 00573. This is a very tricky question. We want to keep only 3 significant figures. So that is 7.00 into 10 raised to 4. So if you open this number, you should get this answer once again as it is. How do we use significant figures in calculations? Rules are very interesting. If you are doing it for addition and subtraction, the result cannot have more digits than the right of the decimal point than the original numbers. Little confusing sentence. Let me show it with an example. Suppose you are going to add these numbers 4.523 with 2.3 and 6.24. We carry out the addition as it is. We get the answer 13.063. Now check among these, which one has the least digits after decimal point? Your answer must be expressed up to that digit only. So you are going to remove the number 6 from here, greater than 5. So we add 1. So we are using significant figure calculations. We are using rounding of rules, everything together. Study this example. 3 numbers are added. You get some answer. We have to check who has the minimum number of digits after decimal point. Your answer should look like that. Over here, we have to remove this number 2. This number is lesser than 5. So we keep the answer as it is. You know, these rules are only used for addition and subtraction. What about multiplication and division? The rules are a little different. We multiply the numbers as given. We check which has the minimum number of significant figures. And we express our answer as that many significant figures. Check another answer. When you multiply this, Significant figures least are 2. Your answer should also be same way. I hope the 2 difference in the rules is very clear. Let us try to solve some problems based on this concept. First one, density of the solution is given 3.121 gram per milliliter. Then calculate mass of 1.25 ml solution in correct significant figures. Let us understand the whole situation first. You have density is equal to mass divided by volume. So when you are doing the calculation, first is the formula. Density is given as 3.121. Calculate the mass. Mass is required. And volume given to you is merely 1.25. So mass is going to be 3.121 multiplied by 1.25. So as we saw, we are going to just multiply these normally and get the answer first of all, which is 3.90125. Now we are going to use the rules which we saw for significant figures. For multiplication, we saw here, there are totally 1, 2, 3, 4 significant figures. Over here, there are 3 significant figures. The rule for multiplication and division is, it must have minimum significant figures. So minimum comes up to this. So your answer will be 3.90 gram. The number which I'm deleting is less than 5. So we leave the answer as it is. So many rules combined together to give you one question. This was quite a recent question asked in NEET 2022. And you will see the question is quite similar to what I solved. Density is equal to mass over volume. Density given 2.15. Mass given is 2.5. They want, mass is given to you to be calculated. And volume is given as 2.5. So mass is equal to 2.15 into 2.5. So when you are going to do the multiplication, it will be just 2.15 into 2.5. So this will be 5.375. Checking the significant figures again. This has 3 significant figures. This has 2 significant figures. Answer must be reported with 2 significant figures. Number to be deleted is this one. So it is greater than 5. Answer is reported this way. So your answer is going to be C. You can see the kind of level of questions you get in exam. I hope you understood all the mathematical part done today. We will continue with more number of questions later, and we go for the third section of topic in the next lecture. That's all. Bye-bye. Take care.